Hello, this is Usana Tantula West. Today in Data Communications and Network 1 class, I would like to show you examples of Huffman coding. Huffman coding is a data compression techniques, okay, that was discovered by Mr. David A. Huffman. It is an optimum prefix code. I have told you this before. It's optimum because it's like the shortest average length code, okay? So it's kind of like base code, okay? But it still have condition to be based, okay? Prefix code means that no code word is the beginning of any other code word. Okay, by being prefix code, okay, the code word, okay, can be decoded instantaneously. We will see in the examples. It can decode immediately after it have received the value of the bit for that alphabet or that symbols. This is, as I say, lowest average length code. That's why it's called optimum code. Okay. This requires the probability distribution of the symbols. So it has to know how frequent each of the symbols will be transmitted, okay? And it uses the unequal probability of the symbols in order to compress. So if the symbol has the same probability of occurring, okay, for example, you have symbol A and B, each of them has 50% of occurring, you cannot compress it will not be shorter than the normal code of 1 bit, okay? So if A is like 90% of transmitting, B is 10% transmitting, then you will have much shorter code than the symbols that have the same probability of occurring. We will see this in the example. It is uniquely decodable means that it has only one answer, okay, for a code word. Instantaneously decodable means that it can decode immediately after it receives all bit of that symbols, okay? There are many ways to explain this, but I will use examples, okay? And I will explain you, I will tell you the step, okay? I will see what happened, okay? Now let's look at how to encode the Huffman code. We can encode, okay, by looking at this. You have the 5 symbols, okay, that you want to transmit, okay, and each of the symbol has the probability of occurring, okay, PS like this. So you can see that okay, this is PS. So this one has the lowest, okay, PS equal to 0.1, right? This one has the highest probability, symbol probability equal to 0.3, okay? And then you order it, okay, from 0.1, 0.15, 0.2, 0.25, 0.3. You order it from the lowest on the right, lowest probability on the right, to the highest probability on the left, okay? Then, so you order the probability, okay? Order the PS. Order the symbol, okay, based on PS, okay? Then you sum, okay, you pair the 2 lowest probability together, okay? So the first step, you after you order the probability, okay, you will pair the lowest probability together. So it's always going to be on the right, okay? So this 0.1 and 0.15, they are the lowest because we ordered them before. So you sum it, you get 0.25. Then you compare. Now we have 0.3, 0.25, 0.2, and 0.25. You compare them, okay? And then you will sum 0.2 and 0.25. You can also sum A and C together, but it will be easier, okay, if you sum from the right, if you have more than one choice, okay. This one you sum to 0.45. Now you have 0.3, 0.25, 0.45. So you will always, again, sum the lowest, okay, the lowest values together. So you sum 0.3 and 0.25, you get 0.55. Then you add them together to get 0.1. This is always 1, okay. We call this the root of a tree, okay. And this is the branch of the tree, and this is the leaf, okay, the leaf of the tree. This is the leaf, okay. Then you assign the value, okay. The left can be 0, the right can be 1, or the left can be 0 and the right can be 1, okay. But I'm using it this way. Now you assign the value like this, okay. 0, 1, 0, 1, 0, 1, like this. Then you encode, okay, from root to leaf. Okay. So you encode like this. So this gonna be 0, 0. AB gonna be 0, 0, and then C gonna be 0, 1, right? And then A gonna be 1, 0. D gonna be 1, 1, 0. Okay. And E gonna be 1, 1, 1, 1, 1, 1. Now you have the code word like this. A alphabet or symbol, okay. Symbol. This is code word. Code word gonna be A is 1, 0, B is 0, 0, C is 0, 1, D is 1, 1, 0, E is 1, 1, 1. Okay. Then you find average length, okay, because this one has minimum average length code, right? So we want to check what is the average length and how much do we save by using Huffman coding instead of no compression. The code word that has 2 bits are these 3, okay. So these 3 probability, so length is 2, probability is sum of these 3 becomes 0.75, okay. And then length of 3, this is 3 bit. Sorry, this is 3 bit, okay. So 3 bits, and probability is sum of this that has 3 bits. Okay, so we have the 2.25 bit per symbols. When you want to find average, okay, of something, it's just a summation, okay. Average length is summation of length multiplied by probability that length occur. Okay, now remember that this is probabilities from 0.1 to 0.3, right? Compared to the next one. This is 0.1 to 0.25, okay? And you have like 0.1, 0.1, so they are kind of similar probability. This case you have 6 symbols, okay? The second example, this is probability of symbols, okay? You order probability, order, okay? Order the probability, okay? From lowest over here, lowest to highest on the left, okay? Then you add, you pair, okay, the 2 lowest probability together, so you get 0.2. And then now you have 0.15 here. Now you have many choice, right? You have 3 of the 0.2. You can sum any of them. They will give you different code words, okay, but they will have the same expected length code. Anyway, I will pair from the right so that the graph look easy. So this one I sum to 0.35. Now we have at this step the two lowest probability will be 0.2 and 0.2. So next I will sum 0.2 and 0.2 together, become 0.3. And this example, I want to show you that we can have a strange looking tree. Okay, so we have 0.25, 0.3, 0.4, and 0.35. So I will sum 0.25 and 0.35 together. Okay, so I get it 0.6. Then I sum 0.6 and 0.4. Again, always 1 here. I assign 0 and 1 to the left and to the right. Okay, maybe over here, so that it's easier to look at. Okay, so 0, 1, 0, 1, 0, 1 like this, and then encode root to leaf to all the leaves. Okay, so this gonna be 0, 0 like this. So these are the code word. Okay, you can, slow motion or look at it again. Okay, this is a clip video. Then we find the average length. Okay, average length gonna be length of 2. Okay, length of 2 is this 3 guy. Okay, probability is 0.65. Okay, length of 3 is this guy. Probability of 0.15. Length 4. Okay, probability of 0.2. We get 2.55 bit per symbols on average. Now, what is the percent safe? Okay, by using Huffman coding. If no completion, we have 5 symbols case and 6 symbol case. Both cases need 3 bits to represent them, right? Because 2 bits can represent only 4 symbols. So we use 3 bits to represent in this 2 examples. Okay, if no completion, 3 bit per symbols. With Huffman code in example 1, use 2.25 bit per symbol instead of 3 bit per symbols. Example 2, use 2.55 bit per symbols. Okay, the decimal point will be important if you are sending, right? Like 100, symbols, then it becomes 225 bits. Okay, instead of 300 bits. So in the first case, you save 25%. In the second case, you save 15%. You can see that the first case, the probability, okay, are different more than the second case. Second case, the probability are closer together. Okay, so when you sum, when you encode with the Huffman code, okay, the one with the different probability will be able to compress more. Now we will decode, okay, quickly. We have the code word like this, and this is what we receive. Okay, receive sequence. We show you if it's we receive 1, okay, bit 1, we don't know what it is. When we get 1, 1, we know that this is A. Okay, so we can decode instantaneously. Okay, after we get the last bit of A, then we got 1, we don't know how to decode. We got 1 again, not sure what it is because we have 2 cases. Until we get 0, we get D. Okay, so at this point we can decode D. This is similar. We get E, we get B, we get C, and then we get E. And so this is the answer. Okay, 1 answer only. Okay, so uniquely decodable. Now let's look at another example quickly. Example 2 to decode. Similarly, okay, 1 don't know, 1 0, 1 1 no. Okay, see, then like this, okay. So we can decode at this point. Okay, at this point and at this point, and only 1 answer. Okay, so this is the property of Huffman coding. Okay, if you want to know more, you can search, okay, on the techniques, okay, on the theory behind it. Okay, and this is to show you simple examples of how to do it. Thank you.